All right, Mr. Richardson here with our third unit in the thermochem unit, heat stoichiometry. So just like we used stoichiometry a couple months ago to go from grams to moles and reactants to products, we can do the very same thing with a thermochemical equation. We can do the very same thing and find out the amount of heat that should be released or absorbed by a chemical reaction. So a quick reminder from yesterday's notes, exothermic reactions are delta H is going to be negative and heat is released as a product. Endothermic reactions, our delta H, our change in energy, is positive and heat is released as a reactant, or is going into the equation as a reactant. So some examples of what that's going to look like. The acidic anhydride, water, acid without water, of sulfuric acid is sulfur trioxide. The change in enthalpy for a reaction between 1 mole of sulfur trioxide and water is negative 129.6 kilojoules. So first question, is heat a reactant or a product? And the clue there, what you should be looking for, is the negative sign. Second question, write the thermochemical equation for the reaction. So really this comes down to writing a balanced chemical equation and then knowing where we're going to put the heat, on the reactant or product side. And part A kind of helps us identify that. Part C then, here comes the stoichiometry. How much heat will be released when 583 grams of sulfur trioxide reacts with an excess amount of water? All right, so part A, the answer is heat will be a product. A negative delta H tells us that heat is a product. Part B, writing our balanced chemical equation, our thermochemical equation. Here's our sulfur trioxide. We add water, we get our acid, sulfuric acid. And because energy, heat, is a product, we place it on the product side. Notice we don't have the negative sign. The negative just tells us which side of the equation to place it on. But here we have it as a product. Part C, here comes the stoichiometry. How much energy will be released when 583 grams of sulfur trioxide reacts? So just like before, our first step is to go from grams of SO3 to moles of SO3. So we find the molar mass of sulfur trioxide is 80.057 grams. Now that we have moles of SO3, we can use our balanced chemical equation, and we can say per mole, we're going to release 129.6 kilojoules of energy. So we just make sure that we get our moles on the bottom so they cancel out. Our energy is on top. Notice we're back to having a negative value. We have to recognize that energy as a product should be negative. We crunch the numbers, simplify for significant digits. We get negative 944 kilojoules of heat will be released from 583 grams of sulfur trioxide. Another example, carbon dioxide decomposes when 43.9 kilojoules of energy is added to it to produce carbon monoxide and 1 mole of oxygen. So what is the delta H for this reaction? Write the thermochemical equation for this reaction, and how many grams of carbon dioxide can be decomposed by the addition of 222.2 kilojoules of heat. So first, they've already told us 43.9 kilojoules of energy is added. To write our balanced chemical equation, again, notice the energy value is positive. That means it is a reactant. So here we have it on the reactant side. So we're going to add 43.9 kilojoules per 2 moles of carbon dioxide to get 2 moles of carbon monoxide and 1 mole of oxygen. Now for the stoichiometry problem. This time we're looking for a mass and we're starting with an energy. So 222.2 kilojoules. Per 2 moles of carbon dioxide, it will yield 43.9 kilojoules of energy. And where do we have those values? From the balanced chemical equation. So important to have a balanced chemical equation because we know it needs 2 moles of CO2 per 43.9 kilojoules. Once we get our moles of carbon dioxide, our next step is to convert to grams of carbon dioxide. That's the unit we're looking for. And we'll finish. 446 grams of carbon dioxide can be decomposed with the addition of 222.2 kilojoules. Notice our limiting amount of significant digits is the 43.9 kilojoules per 2 moles of carbon dioxide. That's only 3 digits. So even though we started with 4, our final answer has but 3 significant digits. All right, your turn. Take a look. See how you do on tonight's homework.